Okay, our quadratic test, I'm going to keep moving along with rationalizing the denominator. And when we want to rationalize a denominator, that means we can't have any radicals or decimals or anything in our denominator. And the way that we undo 3 times radical 2 is by multiplying this fraction by 1. And I say by 1, but it's in the form of radical 2 over radical 2. Radical 2 divided by radical 2 is 1. So what I wind up with is 1 times radical 2, and I'm expanding every detail of this right now just to show you the math. 3 times radical 2, 3 times radical 2. My numerator will just simplify to radical 2. Don't need my 1. The denominator is going to be 3. And then radical 2 is radical 4. The square root of 4 is 2. Radical 2 over 6. If I wanted to rationalize, I'm going to just throw another one on there. If I wanted to rationalize this, just, making something up here. 6 over radical, 14. What do? Multiply the denominator, multiply by radical 14. This one would simplify to, anybody want to try? Over 14. Radical 14 times radical 14 gives me 14. What's the square root of 14 times 14? 14. Yeah, right. Okay. I know when I say it like this, it gets better, right? And then the other thing that I'd want to do is simplify this. I can divide 2 out of this fraction to simplify 6/14. So this would be 3 radical 14 over 7. That's just an additional example of rationalizing the denominator. I started out with 6 over radical 14 and multiplied top and bottom by that. All of which one? I'd rather not. I'd rather just get at the meaty piece. Okay, honestly, well, the height of the ball after 3 seconds, you should be just finding the height. And I'm not going to get to the math here, but I'll show you what you'd have to do. You'd just be finding that. And what's the maximum height of the ball? In this case, this is the y value of the vertex, is what you need here. And I do want to point out in here that this is in standard form. It's just not classically standard like you like it. If I rearrange it into ax squared plus bx plus c, that's what it would look like. And so what I saw in any places where you were trying to pull, if there was errors, it was not using the right a, b, and c values. But that's what would help you, because remember, you need the y value of the vertex. The x would come from negative b over 2a. What was the maximum height? 324? I feel like that was it. Okay, so that's the answer that you would get to. Yeah, I said that, didn't I? Saying it and writing it are clearly 2 different things. So, meatiest piece of this whole one is part C. Find the number of seconds that the ball is in the air when it reaches a height of 224. So what we're doing is trying to find out, here's 224 equals our equation that we started with. This is describing the path of the ball. When is it 224? And so we're into having to solve for t. And there's a few ways that you can go about doing this, but my recommendation is set it equal to 0 and apply the quadratic formula. So that's what I'm going to go ahead and do. 0 equals 144t minus 16t squared minus 224. Now I'm going to have to get a little piece. Now I'm just going to wind up going down underneath here. My a value is, what is it? What kind of 16? Be careful. Yeah, see how this is like you had to go getting it. So my b value is 144, but my c now is negative 224. Okay, so if I'm going to go on and use the quadratic formula now, I've got, I'm going to zoom out a little bit. I'm paying more attention to my video screen than my other screens, so you guys got to tell me what you need. So my intercepts, when the height is 224, is going to be negative 144, negative b. I'm going to do the all over 2a. You guys cool with that? There's my 2a. Negative b plus or minus radical b squared, wrap parentheses around, minus 4a c all over my 2a. This gets tricky. It gets involved. Step by step, I'm going to draw a little line there. Negative 32 in the bottom, plus or minus. Now, I think I'm safe in just, let's see here, 144 squared. It's going to be pretty big. So I've got radical 20,736. And I believe I'm going to be subtracting. Negative times negative, positive times a negative. I'm going to be subtracting from that 14,336. So I'm going to keep simplifying. You try to squish this all together, there's going to be some place you make a mistake. There's going to be. This plus or minus is significant in this problem. 20,736 minus the 14,336 is 6,400 underneath. That's a friendly perfect square. It's 80. Negative 144 plus or minus 80 over negative 32. I had a lot of people give me one answer for this problem, and there's actually going to be two. Negative 144 plus 80 over negative 32, and negative 144 minus 80 over negative 32. Do this math here. Negative 144 plus 80 divided by negative 32 is going to give me my 2. And I know this one works out to be 7. So think about this in the context, you guys. It's the path of a ball. It's going to hit that 224. We said the maximum was what, 324? So it's going to hit 224. It's on its way up at 2 seconds and on its way down at 7 seconds. And you needed both there. Last but not least, just a couple others on this test. Oh, this one's getting long. Say it again, sweetie. Then we'll talk about it in just a second. This will be negative. Number 15 was a biggie. This was about knowing what goes on with the discriminant, and I remember we looked at that specifically in your textbook. And if this discriminant is less than 0, it's going to be a negative number under the radical. Think about that. This discriminant sits under a radical. A lot of people miss this one. If you've got a negative number sitting under the radical, what's going to happen when I have to simplify? If it's negative anything, what comes out from under the radical when I have a negative? Yeah, we've got to think about it as radical negative 1 times x, I radical x. I is going to come out, and as soon as you see that, it means you're going to have two imaginary solutions, which is kind of funny. The solutions are imaginary numbers, and solutions are where it hits the x-axis. And the fact of the matter is that this, if the discriminant is less than 0, you're not going to hit the x-axis at all. We get this imaginary idea. Perfect square trinomial pattern worked out to be choice C. This is a perfect square. The square root of 1/9 is a third. And in factoring, so this would be x plus 1/3 times x plus 1/3. And when I multiply, I'm going to wind up with 1/3 x times 1/3 x, and that's what makes my center term the 2/3. Highlights of the quadratic test.